In the next few slides, we're going to be looking at the concept of buffer solutions, buffer systems. What is a buffer solution? Why we care about buffer solutions, and why we might want to use buffer solutions, and how nature uses buffer solutions very efficiently to regulate pH. A buffer solution, a buffer system, is made of a weak acid and its conjugate base, or a weak base and its conjugate acid. So for example, an example of a weak acid and its conjugate base could be acetic acid and the conjugate base with acetate. The example of a weak base and its conjugate acid, let's say ammonia, it's a weak base, and the ammonium ion. So why do we construct buffer systems? Why do nature use buffer systems? Because it helps us resist change in pH. Let's think of, for example, what happens if you dissolve hydrochloric acid in water. Well, it reacts like an acid, it liberates hydrogen ions, and the reaction stops there. All the hydrogen ions of the hydrochloric acid, all the hydrochloric acid has gone into making hydrogen ions. So a very small quantity of hydrochloric acid, just a few drops, can have a huge impact in the pH of your water solution. What happens if instead of having just pure water, you have water but that has this acetic acid dissolved to it? Well, if you had the acetate base in solution, then it will react with the hydrogen ions, and because it's a base, it accepts hydrogen ions, so you will generate acetic acid and water. So then, of all the hydrogen ions that come from the hydrochloric acid, a certain amount of them will not stay as hydrogen ions, they will react with the acetate to form water. What happens if you dissolve a base? Let's say, for example, sodium hydroxide. If you dissolve a base in water, you liberate sodium ions and hydroxyl anions. So all your sodium hydroxide goes into the water and liberates hydroxyl ions to change the pH, and will make just a very small amount of sodium hydroxide will make the pH very basic, because of all those hydroxyl ions go to change the pH. But what happens if you have a buffer system, a buffer solution in that water? So it's not pure water. If you have the acetic acid and acetate, well, that the hydroxyl ions can react with your acetic acid to produce the anion acetate and water. So what you are giving is, for those hydrogen ions, so those hydroxyl ions, something to react with, which means there are fewer of them, so the change in pH will be much smaller than if they had nothing to react with, in which that would mean that all those hydrogen ions and all those hydroxyl ions would go, it would not react with anything, and would mean a very dramatic change in pH. So how do you make a buffer system? Well, you take an acid and its conjugated base, or a base and its conjugated acid, and you dissolve it, and ideally in identical proportions. And you have something called the Henderson-Hasselbalch equation that tells you roughly what pH they are going to stabilize better. And it's depending on the pKa. So depending on what pH you want to stabilize, let's say that you are doing an experiment that requires certain organisms, you're working with proteins, you're working with something that is sensitive to pH, that needs a particular pH to thrive or to be stable in the case of proteins, then you find a buffer system that will give you roughly that pH. And when you add acid or when you add base, that buffer solution will help absorb those hydrogen ions and hydroxyl ions you're throwing at them, and the change in pH will be smaller. There will still be a change in pH, but it will be a much smaller than if you were doing your experiment, or if you're keeping your organism or your protein in pure water. And how do you know which one to use? Well, you think about pH you want to stabilize for whatever organism or whatever protein you're working with. And you take the pKa of that acid, pKa of that base, and you can play with the concentration of the basic species and the acidic species of that buffer system to give you a slightly different pH. If, for example, if you use acetic acid and acetate, then the pH you're going to stabilize, if you say you have the same amount of acid or base, will be 4.76. So if you want somewhere around that pH, 1 unit below, 1 unit above, then you can play with, instead of putting the same amount of acid that you have of base, you put slightly different proportions, and you can play with those proportions to get slightly different values of pH. And you would use the Henderson-Hasselbalch equation to work out exactly what proportion of acid and base you need for that particular pH you're trying to stabilize, which would be around plus or minus 1 unit from that pKa.